Well, hello, my little geologist. My webcam is still being a little weird, so you're going to have to deal with the voiceover again, but I promise next time I record notes, so on the next unit, not this one, but the next one, you will have my face back again, hopefully. So, on that note, we are going to go ahead and get started. So, I know you are thinking you're going to start on the Igneous Rocks unit, and you will here momentarily, but I just want to give you kind of a brief overview of what rocks are in general before we get into igneous rocks. So, on that, I'm going to open up chapter 2 and we're going to start reading. If we can find it. There we go. Oops, where'd it go? Okay. So, this is chapter 2, classifying rocks. How do geologists classify rocks? If you were a geologist, how would you examine a rock for the first time? You might look at the outside surfaces, but you would also probably use a hammer to break open a small sample of the rock and look at the inside. To study a rock sample, geologists observe the rock's mineral composition, color, and texture. Alright, so already we have a little bit of something here that we need to take care of. So let's go back to our notes. And as you can see, I've started a new notes. This is still under my rocks and minerals notes, but I've started a new section here. So this one is, oops, I forgot already. How do geologists classify rocks? And then under that, I have to study a rock sample, geologists observe the rock's mineral composition, color, and texture. So I'm just going to put geologists study rocks by looking at its mineral composition. I forgot already. Mineral composition, color, and texture. So, let's move on then to the first one. Mineral composition and color. Rocks are made of mixtures of minerals and other materials. Some rocks contain only a single mineral. Other rocks contain several minerals. The granite in Figure 1, for example, is made up of quartz, feldspar, mica, and hornblende. Around 20 minerals make up most of the rocks of Earth's crust. These minerals are known as rock-forming minerals. The minerals that make up granite are rock-forming minerals. A rock's color provides clues to the rock's mineral composition. For example, granite is generally a light-colored rock that has high silica content. That is, it is rich in the elements silicon and oxygen. Basalt is a dark-colored rock that has a lower silica content than granite has. But unlike granite, basalt has mineral crystals that are too small to be seen with the naked eye. As with minerals, color alone does not provide enough information to identify the rock. So, as you can see in this picture here, you see this is the granite. And you guys remember us talking about this a little bit already. There's feldspar, hornblende, quartz, and mica. So, I'm going to come over to the notes. And I'm going to start a new one. And it's going to be mineral composition and color. Oh, boy. Just 1 second. I'm a little OCD, and so I have to have spaces. Make sure it's all the same. Here we go. Alright. So I'm going to go back to my notes. What should we include? Well, we'll put that rocks are made of mixtures of minerals and other materials. Rocks are made of mixtures of minerals and other materials. And then underneath that, I'm just going to put that some rocks contain only a single mineral and other rocks contain several minerals. Some rocks contain only a single mineral, while other rocks contain several minerals. Just so I remember that sometimes rocks only have a single type of mineral, sometimes they have a bunch of other ones. And an example is granite is a rock that has the minerals quartz, feldspar, mica, and hornblende. Oh, how do I spell that? Hornblende. With an E. Hornblende. Alright, so that's what I have so far. In here it talks about rock forming minerals and then granite and basalt specifically, but we're not going to include those because they're not really things that are super important at this moment. I guess we can include the rock forming minerals though. So, rock forming minerals. And rock forming minerals are the 20 minerals that make up most rocks in the Earth's crust. The 20 minerals that make up most of the rocks in the Earth's crust. Just so we remember that for future use. Alright, let's move on to the next one. Texture. Most rocks are made up of particles of minerals or other rocks, which geologists call grains. Grains have the rock or give the rock its texture. Texture is the look and feel of the rock's surface. To describe texture of a rock, geologists use terms that are based on the size, shape, and pattern of the grains. So, and then it talks about, each of these little boxes talks about different grains. And so what I'm going to do now is I'm just going to put in the grains and texture in our notes. So, texture. And so I'm going to put texture, texture. And it said that texture is the look and the feel of the rock surface. The look and feel of the rock's surface. And then I'm going to include underneath that to describe texture, geologists use terms that are based on the size, shape, and pattern. So, let's include, to describe texture, geologists use terms to describe the that are based on the size, shape. Oh boy. Use terms that are based on the size, shape, and pattern. Is that the last word? Pattern of the grains. And then grain. And grain is the particles of minerals and other rocks. Alright. So then it talks about in the reading the grain size. Rocks with grains that are large and easy to see are said to be coarse-grained. Fine-grained rocks have grains that are so small they can only be seen with a microscope. Grain shape. In some rocks, grain shape results from the shape of the mineral crystals that form the rock. Other rocks have grain shape that results from rounded or jagged pieces of several rocks. And then there's grain pattern. In banded rocks, grains lie in a pattern of flat layers or can form swirls of colored bands. Non-banded rocks have grains that do not lie in any visible pattern. So I know from this point you would think, oh, well, we need to make sure we put in talk about the shape, size, and pattern. But when we get into igneous, sedimentary, and metamorphic rocks, we'll talk about each of these more, and so I'm not really going to touch on them here in this introduction. We will talk about them much more in the future. So let's move on to our last one, origin. Using the characteristics of color, texture, and mineral composition, geologists can classify a rock according to its origin. A rock's origin is the way the rock formed. Geologists have classified rocks into three major groups: igneous rock, sedimentary rock, and metamorphic rock. Each of these groups of rocks forms in a different way, as shown in Figure 2. Igneous rock forms from the cooling of magma or lava. The magma hardens underground to form rock. The lava erupts, cools, and hardens to form rock on Earth's surface. So, before we keep reading, I'm going to make sure I put this in my notes. That way I remember. I don't want to get igneous, sedimentary, and metamorphic mixed up here. So, origin. And we say that geologists, let's go back, have classified rocks. You know, we won't even put this part. We're just going to go straight into igneous rocks. Igneous rock. And that forms from there it is. Rocks that form from the cooling of magma or lava. Okay. It doesn't give us any examples yet, so we won't put anything down. Most sedimentary rock forms when small particles of rocks or the remains of plants and animals are pressed and cemented together. Sedimentary rock forms in layers that are buried below the Earth's surface. Okay, so let's include sedimentary rock. And sedimentary rock is rocks that form when small particles of rocks or the remains of plants and animals are pressed and cemented together. Okay? And there's one more on here. Metamorphic rock forms when a rock is changed by heat or pressure or by chemical reactions. Most metamorphic rock forms deep underground. So let's do the last one, metamorphic rock. Rocks that form when a rock is changed by heat or pressure or by chemical reactions. Oops, I spelled cemented wrong up here. There we go. Okay. And then here, down here in the notes, it just kind of shows you pictures. And then, that's it. So on that, you guys are good to go. I will see you again here in a little bit on the flip side for igneous. Good luck!